Good evening, everybody. I'd like to welcome you this evening to Mexborough and Swinton Astronomical Society J.H. Jones Observatory at Hoover, near to Wentworth. Tonight, Peter Lloyd will be giving us a talk on, as you can see, the moon. This should be a live guided tour, all being well weather-wise, and electronically, of course. So, Peter was born in the south of London just before the outbreak of the Second World War. Graduated with degrees in natural sciences from Oxford and finally retired as a systems engineer in 2003. He has been interested in astronomy ever since he was a child and got into astrophotography at the time the webcams appeared. He joined the Doncaster Astronomical Society when he moved to Yorkshire about 5 years ago and is now their General Secretary. So if everybody can please put their hands together and welcome Peter Lloyd. Thank you.
Well, thank you very much, Steve. One minor correction to your kind introduction. I'm actually no longer the General Secretary of the Doncaster Astronomical Society. I quit that about a year ago.
Oh, never mind. They'll be wanting you back soon, I'm sure.
Right. On we go. Right. Moon. Okay. I'd like to start with just a sort of few general introductory remarks before we go to the telescope. I've talked to you before, so I'm sure you all know the major problem I have recalling names. Names of anything, not only people, craters on the moon and so on. So if I suddenly dry to a standstill, you'll know why. And if I'm obviously getting one wrong, Lloyd, don't hesitate to cop in and put me right. So why would we study the moon? Well, the moon is it's a lexicon. It's a history book. It on its surface is written the whole history of the solar system. In that, once we realize that the craters on the moon are impact events, we send probes out and we find craters on virtually every solid body in the solar system, and we use what we learned from the moon to interpret these other places. And if we find a place where there are no craters or insufficient, then it's reasonable to ask why. And of course, one of those places is the Earth, which has more impact craters on it than people generally realize, but nevertheless, not anything like as many as are on the moon. But that, of course, is because the Earth's a dynamic object. It's plate tectonics are moving things around. The crust is being subducted down and recashed and thrown out again. Then we have we're used to the idea that wind and rain and ice and snow and so on weather away our mountains and they gradually disappear. And of course, none of that's happening on the moon. So the moon is a record of everything that's gone on for about the last 4,500 million years. Now, observing the moon, I was asked to give this a sort of tour guide to the moon as we see it tonight. But if you're going to understand everything that is out there and you can see, it's no good going on one night, because the appearance of the moon is quite different from night to night, and it's never the same twice. So tonight we're at about 2 days after first quarter, which is a good time to use it, partly because it's up there in the sky at 8 o'clock at night, and also that the terminator is running down slightly left of center, so we get a decent view of at least the central parts of the moon. The other consideration you have to take into account is the libration of the moon. It basically keeps the same face towards the Earth, but only on average, and it wobbles a little bit from side to side and a little bit up and down. And it so happens tonight that we're almost in the mean position. So there's less than 1 degree of libration in any direction. So that's quite nice, I suppose. Now, I mentioned earlier that we don't get any weathering on the moon. We don't get any rain, snow, ice. Well, there might be permanent ice, but ice is only a problem when the water freezes. But we do actually get rain. It's not water, of course, but we get coming in from space everything from protons in the solar wind to atoms, molecules, little bits of comets that have come off, little solid bits of ice. And of course, astronomers don't only mean water ice when they talk about ice. It means anything which is normally a gas which is frozen, so frozen nitrogen, frozen carbon monoxide, frozen methane, or whatever. And then we've got the bits that have been shed off comets, little bits of dust, little grains of sand, the occasional pebble, and of course, very occasionally larger chunks. And these have been raining down on the moon for the last 4,500 million years, and it's continuing today. And we'll see in a minute why that's an important consideration. Now, you'll be aware, I'm sure, that when the geologists were studying strata in the Earth and were trying to work out the history of the Earth, they created a number of eons or period zones or something, you know, the Jurassic and the Pleistocene and things, because they didn't know how long ago these things were, but they could put them in order. And using the technique that you still see if you ever watch any of the programs about archaeology, you see stratigraphy in action as they scrape away. And the idea is if A overlies B, B must be older than A. And exactly the same thing's been done on the moon. In the early stages, people were able, by very careful studying of all over the moon, to put most of its things into a set of periods. And just as on Earth, when various means to date rocks came in, the geologists were able to put years on their ages. Exactly the same thing now applies to the moon, because the kind Apollo astronauts brought samples back, and these have been dated, and so we actually now know the true periods of a lot of these things. So it will be handy, while I'm talking about the origins of things, to use these. Does my pointer show? Does that show, Paul?
Yes, it does.
Oh, good. To use these names. I've given you the dates over here as well, but I really largely ignore those. I don't think they're particularly important, except they're interesting. So this is from the most recent time, back in time. So we're currently in the Copernican age, which goes from today back about 1,100 million years. Prior to that is actually the longest period of lunar history, in the Eratosthenean age. Bit of a mouthful, that one, and I trip over it every so often. Prior to that, there was only one age here, the Imbrian age, which starts 3,850 million years ago with the creation of the Imbrian Basin. But when the Orientale Basin was discovered and dated, it was realized that it fell about 100 million years after the Imbrian impact, and was another useful date marker. So the people who decide these things decided they would split the Imbrian at the point where the Orientale Basin formed. And they named it the Upper and Lower Imbrian Age. And this confuses the hell out of me. To my mind, they've done this the wrong way round. To me, the upper would have been the older and the lower the younger, but they've done it the other way round. So I'm not going to use those terms at all. I don't think they're particularly helpful. Prior to that, we have the Nectarian age, which is a relatively short one. And then pre-Nectarian, before everything else, which takes us right back to the origins of the moon. Okay, now, if I can do it, I will switch back to the telescope. We had the camera the right way up originally, but it's had to come out a few times, so it's a wee bit tilted now, but not to worry. I don't know, can we increase the contrast at all? It seems to have... What happened? It's frozen.
No.
Look.
No.
And then what do you want to do?
No, that's all right.
Okay.
It could be a little bit brighter, gentlemen.
It could be a little bit brighter,
Okay.
and you can probably zoom in a little bit. Yeah, that's better.
What's that like for you, Paul?
Oh,
That's
too much.
that's far too bright.
That's too
Turn your monitor down.
No, right.
That's lovely.
A little bit more,
A little bit more.
just a touch.
Yeah,
That'll probably
we've got
do.
the limb. Right, so what do you want now? The resolution.
Yeah, if we could zoom in just about one.
Right, let's
one
just,
click.
just want what we want. A bit more.
A bit more. That'll probably do.
Can you see that okay, Paul?
That's brilliant.
Yeah, it's quite nice, isn't it?
It's
Oh, I've
like
got-
being there in real life.
Yep, here we have the moon in real life, as seen by a very fine camera stuck on a very fine telescope. Okay, so I thought we'd start the tour up at the North Pole. Now, you have to remember that the only source of light on the moon is the sun. A tiny bit of earth shine, but that's really not important. And we only see things at all because they cast shadows. Now, people think there aren't many craters up here in the north, because that there are, but it's just that all their edges are rather dull. The mounts are quite small, and so they cast very little in the way of shadows. So we don't see very much. This, for instance, looks like it's actually labeled sometimes a walled plain, but it's not. It's a series of craters which have been filled in, because this is just north of the Imbrium Basin, which is this down here. And that most of these craters up here are Nectarian age, so they formed before the impact that produced the Imbrium Basin. And that, of course, was a mighty great impact, and it sent what we call ejecta, masses of dirt and dust and rubble and bits and bobs of stones and rubble, and it just plain filled these craters in. And the bits that are left sticking out were also battered like blazes by all these bits of rock streaming in and hitting them. So you end up with very rounded hills with very little height to them. In fact, I went in and measured a few of these, and they're no more than about 800 meters high, which is tiny compared with any reasonable crater. So you don't really think you're seeing craters here, but actually you are. And it's made slightly worse by a crater which I think is just beyond the terminator, called Anaxagoras. And that's a Copernican age crater. So it is has scattered fresh looking rock all over this area. And the definition of a Copernican age crater is that you can see its ejecta pattern. The ejecta tends to come out not as you might think as a sort of even veneer of material. It tends to come out in strips and stripes, and it calls what we call rays. They're not easy to see at this sort of phase. They show up best at full moon sort of stage. So that's why things look rather dull up here. They've been filled in with the ejecta from the Imbrium Basin, and they're all horribly bright, which I perhaps should have mentioned. If you do want to look at the moon through an eyepiece, it's well worth putting a moon filter on, which is basically a neutral density filter with I forget what the density is. It just cuts down the glare and makes it much easier to see. So if we move south, hopefully if I move this, yeah, there we go. The first thing we obviously come across is this rather strange dark stripe across here. That's the Mare Frigoris, the cold sea. What else would you call a sea in the far north? And that is very odd. It's the only mare on the moon which is not roughly circular. So where the heck did it come from? you expect them to be circular because they are an infill of large craters, basins, which are essentially roughly circular. So we might come back to that, but it is a bit of a mystery as just where that came from. If we come a little bit further south, we get this rather nice crater here. I don't know whether I can zoom in a little more on that. That might be fun to try. Whoops. Oh, this is fun. Except it doesn't seem to have come in. Oh, that's better. There we are, a nice close-up view of Plato. Now, Plato's a big crater. I'm afraid I don't really remember sizes. It's about, I don't know, 150 kilometers across, but it's relatively shallow. And if you look, even with a good telescopic camera, you can't see any craters on its floor. There are some, but not very many that are easily seen. And it's quite often used as a test of the acuity of eyesight or the quality of your optics or your seeing. And I guess the seeing tonight isn't brilliant, although I must admit it's better than I feared it would be. And so we don't see any craters on the surface here. And one of the ways that areas of the moon can be aged is by counting how many craters there are. So it makes it look as though this is relatively young. And don't ask me what I mean by relatively young. But it's dark, so it's almost certainly basalts. Now, I should have mentioned in my preamble, the moon is essentially covered in one of two types of rock. It's covered by basalts, which are volcanic lava, which is spewed out of a volcano at some stage or other. And the highlands are a mineral called a northosite, which is a light mineral, both in density and in color. So the light areas are a northosite, as it were, floating to the surface, and the darker areas are the basalts. Now, this is evidently basalt, but it also evidently does not connect to down here, which is the Imbrium Basin, or up here, which is Marifericoris. So where the heck did this come from? And there's really only one place it can have come from. It must have come up through the floor of the crater, which must have fractured at some stage after its formation. Now, it must have formed after the Imbrium impact, otherwise it would have been obliterated by it. And it's a bit difficult to know quite where this whole feature here came from. Does it represent the outer edge of the Imbrium Basin, or is that out here somewhere, which would explain this sea here? So what I thought we'd do is to roam gently around the Imbrium Basin, and we'll look at some of the features that outline it. And if we move down here, we find a really modest set of mountains. These are the Lunar Alps. But through them is this feature, the Alpine Valley. And if you've got really good seeing conditions, there is a rill that runs down the vent, a little fine winding crack runs right down the middle of it. And actually, you can just see a bright shadow a bit across there. It actually changes level at about that point. It does, in fact, connect out here. There's a gap in the mountains here. And this is almost certainly what the geologists call a graben. Two faults have formed, almost parallel, and then the ground in between has sunk. This happens in volcanic areas, and you get them on the Earth as well. So those are the Lunar Alps. We carry on down here. We come to the embarrassing set of mountains. These are the Caucasus, and nobody knows why they're where they are. They're not arcuate to either the Imbrium Basin on the, sorry, I'm waving at my picture, you know what I'm saying? They're not part of an obvious ring around the Imbrium Basin, nor are they around this, which is another ancient basin, the Serenitatis Basin. They're somewhere in between. And it's very difficult to see how on earth they got to where they are. I had the sudden thought, well, no, I'll come back to my sudden thought. So we'll come on south and ignore Caucasus Mountains and come to the majestic mountains, or the highest mountains on the moon are in this range. These are the Lunar Atomizers. And of note here, this is where Apollo 15 landed. This is the Palus Putridinus, the stinking marsh. And they landed round about here, which it was a pretty remarkable piece of navigation when you think they came in from this direction. They came in this way, came over the mountains there and came down between these two quite massive mountains. I guess we've got some cloud coming in.
Yeah, it's just gone.
Are we on auto whatever?
Yeah,
Well,
I think we're not
well,
much sure.
it's coping quite well. And there is a little narrow crack runs round here called Hadley Rill, and we won't see that. I'm sure you could with this telescope and perhaps a more powerful, I don't know if it was seeing was better and we zoomed in, we might see it, but it's not an easy object to see. And in fact, the highest mountain on the moon, I think, it's either that one or that one. It's Mount Huygens, I think it's that one. And it's about 4 kilometers high, if I remember rightly, but I may well not do. And if I can zoom out a bit, a little more. Sorry, I didn't get the chance to practice this. There we go. I think you can now see that those mountains are curved. They're part of an arc which basically surrounds the Imbrium basin. You expect this. These are impact basins. They're very like craters. They're just big. And you get this outer wall, and this is absolutely typical. It's very steep on the inside, relatively shallow on the outside. And it's really a matter of deciding, if you want to decide where this ring goes, is how you construct the circle through this part. Some people bring it out so that it vaguely includes the Caucasus Mountains and disappears up there. Personally, I prefer to keep it a little further inside and bring it round and up the Apennines. But they're an odd set for a basin. That moved a bit quickly. Okay, so here they come round here, and this gives us a chance just to talk momentarily about these two craters. I'll take this one first, which sadly is not well displayed. It's too near the terminator, but this is Copernicus. And this is the crater after which the Copernican age is named. And the definition is that you can see the rays that come out. And you can, even at this phase, you can see them. They're not well displayed at this phase. You want to look at full moon to see them. Now, the division between the Copernican age and the Eratosthenean age, and this is Eratosthenes, is that Eratosthenes does not show any rays. You can't see any round here at all. And what's happening here is the fresh white rock that is thrown out by the impact event and strewn all over the place. This gradually darkens down as these micrometeorites come in and just pick away at the surface. And the surface becomes pitted and as a consequence darker, because the sun starts to cast shadows within these microcraters. And that, on average, darkens the surface. And it takes roughly 1,100 million years for a nice bright ray to finally weather down to the point where you can't see it anymore. We can go, I think, a little bit further this way.
Yeah, just clouding over a second.
We're back. And the ring continues probably through these, which are the Carpathian Mountains, and they're not very impressive either. Now, I can't take you any further round, and that's probably just as well, because there's nothing there to see. If we get, whoa, what have I done?
Careful, we've got cloud again. Yep, don't worry.
Ah, right. I thought I'd moved it too much.
No. Going back.
Ah, yeah, something there. Yes, that's better. Good, excellent. Right, sorry about that, folks. Let's go back to where I was. Yeah, I was just really commenting that I can't show the rest of the ring around the Imbrium Basin because it's in shadow. You'd have to come back at near next phase up, as it were, to see that. But it is odd that there is, oh, get my finger out. You've got the massive Apennine Mountains here. The Alps are much more modest here, and they're diametrically opposite the Carpathians, which are sort of, what have I done?
So, there you go.
Which are also fairly modest. And on the opposite side from the Apennines, there are no mountains at all. And it looks to me, and I don't know how official this is, that the Imbrium Basin formed on a slope. And there has been proposed that there used to be an even bigger basin here called the Gargantuan Basin, which and the Imbrium Basin, if that formed on the side of that, then the whole Imbrium Basin is sloping, and that would account for the slightly abnormal way the mountains are arranged. Now, the infill of the lavas undoubtedly occurred quite a time after the formation of the basin, because now if I dare try and zoom in a bit. Yes, if you look carefully at this crater, which I think is Archimedes, then it evidently predates the lava. The lava embays it. You can see a fairly normal glacis around the side, but it looks as though the lavas came up and then surrounded it. The crater itself, of course, must be post-Imbrium, and the lavas must have come in later. And compare that with this one, which is an Eratosthean. No, it might even be a more recent one than that, because you can, in fact, see rays coming out of it. So
It's Aristillus.
Sorry?
Aristillus.
That's Aristillus, thank you. And that postdates the infill of the lava. Now, don't think that the lava infill occurred at any particular time. It almost certainly happened slowly in waves every so often for maybe 100 million years or more. And the lavas on the moon were undoubtedly very fluid. They seem to have flowed over vast distances, which makes, and some of you can tell how thick they are if you find the front. And I don't think we're going to be able, there is one place here where you can actually see the lava front. No, it's in the sinus iridum, and we're not seeing that. But these lava fronts are only a few tens or hundreds of meters high, so they're quite thin. And yet these lavas have spread thousands of kilometers, hundreds or thousands of kilometers across the surface of the moon. And it seems to me they must have been extremely fluid to do that. If you've ever seen pictures of lava flows in Iceland and places like that, slowly creeping downhill and slowly pushing houses over, they weren't like that at all. They were much more like the lavas you get in Hawaii, which cascade down the sides of the mountain almost like water. And the lunar lavas must have been like that because they've spread over huge distances. And I reckon they must have been very hot, because surely to goodness they must be cooling to space very rapidly. Okay, let's move away and we'll zoom out a bit. I must say I like this facility, it's very nice. Right, here the Apennines again, and if we move up here, where are we? Yeah, we come to the Serenitatis Basin. Now, I did wonder for a moment whether the position of the Caucasus that's these mountains here that I pointed out with just all in the wrong place. If this curve of mountains would believed to come out here and curved around here, maybe it wasn't that these got pushed that way, maybe this whole section here got pushed the other way. And I thought that was a really bright idea until I looked things up and found that the Serenitatis Basin here is a lot older than the Imbrian Basin, so it didn't happen like that. Now, I think we move down here. We can get to probably the best known mare on the moon, Mare Tranquillitatis, the Sea of Tranquility, because of course that's where Apollo 11 landed. And if I've got myself right, it landed somewhere in this area here. Having come in from this direction, and if you remember, Neil Armstrong had to take control and overshot his landing space by quite a long way. And if he was coming in this direction, he didn't have that much further, he could go on. But at this point, I must talk for a little bit about what I always think is one of Roy's favorite craters. And it's grossly overexposed. It's a little crater here, it's quite small. We can tone it down a bit. That control. That's lovely. Oh, super. Yeah.
Just a bit more.
Yeah, that's one. Yeah, we can now see it. This is Proclus. It's quite a small crater. Sorry, I don't remember sizes. 14 kilometers across, if memory serves me, which it often doesn't. But it's a Copernican age crater because you can see all the rays streaking out of it here. But in particular, there are these two very bright rays here and nothing in this area at all. And that is absolutely characteristic of an impact that's been caused by a missile coming in at a low angle, certainly less than 45 degrees. And in my opinion, the width of this angle here is such that I think these came in at a very low angle. Maybe, I don't know, I'm guessing 20, 30 degrees. And when that happens, all the ejector gets thrown forwards. And for some reason that I can't explain, but I'm sure the physicists can, you get these two bright rays in the slightly backward direction, and then nothing in where the missile. So that came in this direction at a low angle and hit there. Now, it raises the interesting point that this area here has a name, which I've, of course, forgotten. Pallas, did I write it down? I have a crib sheet that I'm not using. Yes, Pallas Somni. What would that be? The marsh of sleep. And it looks like a well-defined, pale area bounded by these bright lines. But that name was given to it before it was appreciated what the significance of these bright lines is. So I went into the lunar orbiter pictures and I had a look at this area. And this boundary here could be real in that the land here is rather more rugged than it is in the Pallas. But on this direction, apart from the change in albedo, the brightness, the land in this direction really doesn't differ from that here. So the fact that the Pallas has been defined up to this line is not really particularly meaningful. Okay, let's move a bit further. And we get to this lovely big, I'll zoom it out a little bit, I think. Mare Crisium, this nice circular bit. This, I don't know, people see different things. This area to me is the old man and his bundle of sticks, and here's the bundle of sticks. This looks as though it's not circular, but remember we're seeing the moon as a projection, and objects near the limb become distorted, so they become compressed. So this diameter of the sea has is shorter than it looks shorter than it really is. And in fact, it works the other way. The Mare Crisium is slightly elliptical, with this being the short axis and this the long one. And it's believed that maybe because the very large object that came in and hit and created it came in at a shallow angle. And that takes one back to the thoughts about what happened when the moon formed. It's probable that the moon formed by an accretion of material that was in orbit around the Earth. In the sort of latest theory about the formation of the moon, by the grazing impact of a Mars-sized body, threw a lot of debris into Earth orbit, and this gradually collected together to form the moon. But why would it all form one object? It almost certainly would have formed several objects. And these objects later came in and congealed with the moon. So, and it has been shown that if a body is essentially in orbit around the Earth, but gradually gets pulled in, it will go into orbit around the moon and spiral inwards. So it's not at all unlikely that many of these last impacts came at a shallow angle. And Crisium almost certainly did. Okay. If we go a bit further south, doesn't want to move. There we go. In fact, this is Mare Fecunditatis, which isn't, it's a very, very old, nothing much to say about it. This one is Mare Nectaris, and that's what gives its name to Nectarian age, which starts when this was formed, sort of about, what was it, 500 million years after the main accretion of the moon occurred. And any craters which occurred before that are extremely difficult to see, because they've been battered out of existence by all the ones that came in later. It's really only Nectarian age craters which have survived enough to see. Now, here's down here another pair of nice Copernican age craters. They show up beautifully. I mean, at almost any phase, these show up as two vividly bright spots. They're actually quite small craters. Again, I forget, it's Stevinus P, and I've forgotten. But more interesting, but which I sadly can't show you live, is this crater. I think it's this one here. That is, and the name has escaped me.
Langrenus.
Langrenus?
Is it Langrenus? Langrenus?
Well, if it is, it's not the one I wanted. Patavius was the one I wanted. But I find it quite difficult to find these things when you can't see them clearly. So it might not be that one. It might be. Whoop. It's here somewhere, but it would be nice to be able to show you, because it's a lovely example of what's called a floor fractured crater. Some craters have cracks on the floor, and Clavius happens to have a particularly marked one. In fact, it's probably a graben. There are others. I don't know whether it will show up, even if I know where to find it. Well, let us bother with that for the moment. We'll go to, oh yes, this set of craters here, which is rather a nice set, and do illustrate a few points that are worth bringing out. Oh, nice. Sorry. Lovely. Yeah, they're coming back. The big one is Ptolemaeus, and I don't know this one. Again, I'm sorry, I don't remember sizes, but it's big. It's 200 kilometers or so across, something of that order. And again, it seems to be relatively flat with one small crater in there. Alphonsus is this one, which, oh, notice Clavius doesn't have a central mountain. Where's that gone? Albertiginius, that doesn't sound right, has this one small, and it really is a tiddly little mountain. It's about 500 meters tall. But what's interesting, and you can see it here, it's got these little dark patches on the floor. Now, you might, looking at this, think it's lava. It's, you know, it's like Plato, isn't it? It's got a flat floor, lava's welled up from below. But that's not the case, because if you look carefully, this is a lava field, so is this. They're much darker than this. This is not dark enough to be basalt. And this is, guess what? Imbrium ejecta, because the Imbrium Basin is only a little way north of here, and it's spread its mess all over the place. And these are pre-Imbrium craters that got filled in with the ejecta from the Imbrium formation. This is a fascinating little crater. I think even at this resolution, you can tell that there's something funny about its central mountain. If you compare it, we've lost it. Oh, I see. I didn't realize I could do that. I should have done that more often. Yeah, I think you can see it fairly clearly now. Yes, that's much better to do that. This little crater here, and compare it with this one. This one is a fairly normal crater for its size, with a nice sharp central mountain. But the central mountain here isn't a mountain, it's a sort of mound. And to be quite honest, I don't think anybody knows why that to form like that. It's almost certainly a volcanic effect of some kind. You get lavas coming up below craters and pushing the floors up, which is what cracks the floors, and you get these floor fractured craters. And so there is some sort of volcanic activity gone under here. And there have been reports of volcanic activity in Alphonsus. It's sort of well known for that. Whether they're real is, I think, a slightly another matter. But it does have these little dark areas that you can even see here. One there, there's certainly a very clear one there, and some down here. And it is thought that these are probably cinder cones. In other words, they're little volcanoes that have shot out a bit of sort of volcanic ash, which is dark, like the lava fields, and leaves these dark spots. So some sort of activity has gone on down there. It's difficult to say much about a lot of these. No, can say something about them. I thought there was a maybe. Okay, let's just go down to the south or the polar area, and here's where you see all the craters. And I'm not going to bother you with the names of most of these. This one's well known. This is Clavius, and if you're a science fiction fan, that's where Arthur C. Clarke put his lunar base in the 2001 story. That was in here. And this is evidently old. It's got lots of craters inside it, a reasonably flat floor, but that's probably ejecta either from the Aitken Basin, which is further down, sort of around the back, or possibly from the Orientale Basin over here. But north of it, of course, is probably the most, oh, I'm doing the wrong thing. One of the most famous craters around here, which doesn't show up that well, this is Tycho. This is the source of this terrific ray pattern, which you can see it beautifully at full moon. You can see it with the naked eye at full moon, this bright patch at the bottom of the moon. You can even see a sort of dark halo because there's a dark ring around it. And that is a very pristine Copernican age crater. In fact, we know better than that. We actually know that that crater is 105 million years old. How on earth do we know that? Well, I have to admit that even I'm a little bit dubious, but if I can zoom this thing out a long way, I'll try the full amount. If we go up, and if I can find it, it's not always certain. Yeah. Apollo 17 landed somewhere in this area. I think it was, yeah, 17. Now, it was known, and you can't see it here, but it was known that at the base of one of these mountains, I think it's, no, that doesn't quite look right. Anyway, it's this area somewhere. Oh, that's nice. Yeah, it's not that one. It must be further in here somewhere. Sorry, I find it quite difficult to orientate myself. But Apollo 17 landed in this general area, in among the mountains. And it was already known there was a bright patch of material at the base of one of the mountains. And it was extremely difficult to see where on earth this material could have come from. It was too bright and too new to be any of from the immediate surroundings. And the conclusion was drawn that it actually came from Tycho. Under very good conditions, you can sense, oh, I'm doing it again. I think I've lost it there. Yeah, you can see it actually here. You see this bright streak running across here. Quite a few of the bright streaks. I think if we pan back, and I'm risking my neck here, that will point at Tycho. Yeah, pretty well anyway. And it is reckoned that when Tycho formed, it does undoubtedly created rays that stretch right across the moon. And it's thought that one of those, the material from it, hit that mountain, slid down, and it's among the samples brought back by Apollo 17. And in that sample are little tiny chips of light-colored rock, and they can date it from when it was last shocked. Now, I've no idea how they do that. My daughter has a degree in geology, so I asked her, and she didn't know either. But they can, and that is the 105 million years. Well, how are we doing time? I think that really concludes my tour.
Thank you, Peter. Now, can we leave the line open? And we'll leave it like this. If people have got questions about specific items or objects on the moon,
I can go and try and find them, yes.
Yeah. Okay, so ladies and gents, and I'm really going to need digital hands today. So I'm looking for digital hands, please. So John Leach. John, can you unmute yourself?
Good evening, all. Peter, that was absolutely excellent. I have really looked forward to this.
Thank you, John. I wasn't that pleased myself, but thank you anyway.
Oh, this is the sort of thing I needed because Roy helps me out so much, and you do. But to actually have a guided tour like this.
Can you hold on a moment, John?
Yeah.
Can you raise the volume?
Paul was loud, so.
John,
can you shout?
Windy up here.
Sorry, John, I'm a bit hard of hearing as well.
Right. Can you hear me now?
Yes.
Is that better? Yes. To have a guided tour, to have the moon in front of you, and to be guided through is you can't get that in a book. You can't get that in an image. You need that person to guide you through. And I've learned so much from this tonight, Peter.
Oh, well, thank you, John.
And what I've done, I took some shots earlier, and what I've been doing is looking on my images to see if I can see some of the physical characteristics. So helpful, absolutely spot on.
Oh, I'm sure among your collection, John, you will have some lovely images of some of the things I haven't been able to show you, either because they're off into the west, or those craters on the east. If you've got some of the crescent moon, I think you'll be able to see them there. I can see them on the high resolution pictures I took, and yours are probably better than mine.
If you ever need, you're welcome to any of my moon images, Peter.
Well, thank you, John. You've said that before, and I really appreciate that. And had I not been able to come out here tonight, I was going to do it from home with photographs. And I hadn't actually called on you for one, because I could find a couple I felt reasonably satisfied with of my own. But thank you, John. I really appreciate that. Your images are so good, they need to be stored somewhere publicly, in my view.
I send them to Roy, so they're backed up.
Well, yes, I suppose. Do you keep all your gallery images, Roy?
I do. I'm all on file, and one day we might even have a calendar one year with images on.
Oh,
That's a good idea. Yes. 12 phases.
Okay, John. Thank you for that. Philip Muffet has a question.
Well, it was not a question. All I'm going to say is, if you go to Crisium and then go a bit to the right, there's Mare Marginis. It's right on the limb. Could you just go and have a look, see how well you can see it?
Mare Marginis.
Yeah, it's right on the right hand side.
Yeah.
I thought you were gonna go to Marginis after you've been to Crisium, actually. Oh, I can see it. You can just see it. Your mouse is nearly on it.
Just about see it. That's here, isn't it?
Yeah. Can you zoom in? Because that's a really good see.
It's just that the libration is not very favourable for that area.
Yeah. Well, that's a really good
Phil,
yeah.
Phil, if we zoom in, it's an extra £1. But that's only for people with analog hands.
So it's a really good see.
What I like in this area is this feature here, which doesn't have an official name, but Charles Wood in his book calls it, and he gives it the Latin name, but which I can't remember, but the Lake of the Cat's Smile, because it looks like the Cheshire Cat with Alice in Wonderland.
Smiling cat.
Faded slowly from the tail forwards until only the grin was left.
Yeah. So it's a really good area to see how it's librating.
There are a number of these mare right on the limb, which only really show up well when the libration's favourable.
Yeah.
I don't like to push it, but if you go on my website, you'll find some pictures at favourable libration.
Yeah.
I like doing the libration zones. It's a real challenge because the light is never right.
Yes.
And the problem tonight is why we can't see much. Around here is simply that on the moon it's midday here, so the light's coming straight down and there are no shadows. And when no shadows, you don't see much.
True.
Okay, Peter.
Sorry, Phil.
That's really good. And the other thing is, it shows how bad the scene is tonight, because that is really wobbly. I've got to say, the image and the photography is absolutely brilliant, but obviously the atmosphere is really, really wobbly.
Yeah, actually, it's done remarkably well. I must admit, I didn't think we would do this well. The forecast was although it was said that the skies would be clearing, the seeing was rubbish. But actually, it's really quite good, isn't it?
You've got a good image, although it looks like a pan of boiling water, but it's a really good image.
Yeah, yeah. I mean, we've got a super telescope and a very fine camera, and the seeing conditions must be reasonably good. Yeah.
Yeah.
Okay.
Anyway, thanks for the guided tour.
Thank you, thank you, Phil. Peter, a question from me. You said you had a sudden thought about the Caucasus Mountains, and then you didn't finish it.
Oh, didn't I?
No.
Well, it was a wrong thought. Got to find them. There we are. If I actually, let's zoom right out. There we go. Yeah, it's a case of where you draw the lines around. If you use the Apennine range as the arc of the outer ring of the Imbrium Basin, which is what they appear to be, what actually seems to happen here is you get a perfect arc of a circle, but it then bends outwards and comes up to the Caucasus. So something very odd has happened, and it depends where you take the circle, leaving the Apennine Mountains. And most people draw it round here and tend to take, oops. Oh, I know what I'm doing, and I'm zooming the blooming thing, aren't I? Oh, maybe I'm not. And again, somewhere on my website, you'll see that I've actually drawn circles in. And I think you can draw a perfectly good circle through this part of the Apennines, which then rolls around and goes through the, you stop doing that, through the Alps and up here. And if there were an outer ring that has disappeared, and I have to admit there is absolutely no evidence for an outer ring at all, but it would come up here through all these mountains and might explain Mare Frigoris. Because if you look at the Orientale Basin, which is a beautiful, pristine, multi-ring basin, and you can see about 3 of the rings, there are lakes sitting in between the rings. And it seemed to me that if you could argue that the Imbrium Basin ring, I'm moving the wrong thing again, the Imbrium Basin ring, this was an inner ring and that's the outer ring, you could explain Mare Frigoris as a lake that formed in between the 2 rings. And because the whole thing's on a slope, its lava's merged with all the lava's out here, so it doesn't really look like that. And I didn't mention these odd, come back. These odd isolated mountains that you get in Mare Imbrium. If we go here again and zoom in a bit. A bit more. Sorry, trouble having gloves in, you can't feel anything. And one finger is getting frozen operating the touchscreen. I'm really trying your mount. Yeah, that's almost there. And you've got these odd mountains that stick out of the lava around Mare Imbrium. This is I think this is the straight range, and I forget the others have have names, Mons, Pico, and I'm not sure these are. But it's thought that they are, in fact, an inner ring of the Imbrium Basin, which stuck up enough that the lavas haven't covered them over. Oh, I didn't answer your question, did I?
I thought that was your thought about the Caucasus Mountains being part of that ring system.
I didn't answer your question, and it's always one. I'm not a politician, but it's the way politicians fail to answer questions, isn't it? By getting distracted and doing other things.
I think the technical term is pivoting.
Oh, is it? Oh, well, I was pivoting, yeah.
I call it something else, Paul.
My thought, Paul, was that the arc of the outer ring of the Imbrium Basin might have actually come out here and round and through the Caucasus Mountains up its way. And that what happened wasn't that the Caucasus got pushed this way, but that this whole section got pushed that way. Okay? And yes. I thought, well, maybe when this impact formed, one thing it couldn't do that. Are you sure? No, I'm not. And if the ring was originally out here and Serenitatis formed, maybe it pushed all this lot that way. But that doesn't work because this basin is older than this one. And what's the evidence for that? Well, the evidence for the ages of these things is really, you look at the outer, this Serenitatis basin, it has a bit of an arc ring here, but on the whole, there aren't, where are the rings? They're simply not there. They've been bashed away by later impacts. So this is an old basin. And in fact, all these basins down here are old. In fact, other than Imbrium and Orientale, Nectaris is the youngest of them. And that, as I say, gives rise to the Nectarian age. And you can see that looks very battered. Well, it would. Yes, you see, it is roughly circular, but you can't really see any edges to it. There is, in fact, an edge. Yes, you can just see it here. The Altai Scarp, which looks like very much like as it might have been the outer ring of this basin. They're distinctive in that they're steeper on the inside than they are on the outside. But I know one thing I did mean to. Is Huygens sword on view? Where's Huygens sword? I can't remember where it is. Help me out, somebody. Where's Huygens sword?
Oh, no, that one. Sorry.
Well, not to worry. All I was going to say was that you can get very false impressions about slopes on the moon. If you go into the Lunar Reconnaissance Orbiter quick map, it can show you altimeter data, and it can show you the shapes of things. But it's very, very deceptive because the vertical scale is much greater than the horizontal scale. And I don't believe there is a vertical cliff on the moon anywhere. I've never found one. And this Rupes Rector, the sword of Huygens, which I want to know where it is, and I've forgotten. Come back. Anyway, I did the height maps on that, and it's about 300 meters high and a good 2 kilometers wide. So the slope is actually very gentle, even though it can look, whoops, there it was, well done. Wrong way. Get around there.
It's good. It's good.
Thank you. Well, anyway, I would say that, and you get the impression that craters have very sharp inner walls. They don't. I think I did talk about that once before in a talk and showed you what these craters really look like, and they're not. They're quite shallow hollows, really. Anyway,
Well, thank you for that. Thank you for that, Peter. I'm looking around just one more time for questions. As I said, digital hand would really be useful. Other than that, wave at me. No, oh, John Leach.
Yeah, just a quick
John,
question.
can you speak up a little?
Yeah, a quick question for Peter. Peter, do you use any filters when photographing the moon?
Sorry, can you say that again?
Do you use a filter?
Oh, no. Sometimes I will take it in the near infrared. I think you get quite nice pictures in the near infrared, but I think not with the DSLR. To do that, you need a monochrome camera. I tried it with my modified D600, and it was really very interesting. You see, in a color camera, you have filter chips filters on the individual pixels on the chip.
Yes.
And it all depends how transparent they are to the infrared. Now, in the old days of the 2UCAM, marvelous little webcam that was, because all the color filters were transparent in the infrared. So if you took it with an infrared pass filter, you got a monochrome picture. But do that on the D600, and it really is quite amusing. The blue filter is quite transparent, so that comes up bright blue. The green filter is not quite so transparent, so they come up a sort of dull green, and the red filter is opaque, so you don't get any red in it at all. And it really produces very mucky coloured pictures. What happens if you sort of like Tony's done here, put the picture into monochrome? I'm not sure.
Thanks for that, Peter.
Okay, ladies and gents, I think we have worked Peter Lloyd incredibly hard this evening. It's been a wonderful night, and thank you for being our guinea pig, really, Peter, and trying this system out for us, showing what we can do.
Well, thank you for inviting me, and thank you for giving me the chance to see these pictures through your lovely big telescope.
Our pleasure. Ladies and gentlemen, can we give a big Mexborough and Swinton Astronomical Society thank you to Peter Lloyd. Thank you, Peter.
Thank you.